Bacteria, as everyone knows, are responsible for many illnesses and diseases. But the particular bacteria that are responsible for 80% or so of these urinary tract infections are a form of E. coli. These are a particular strain that have adapted to survive in the urinary tract. And the way they are infectious is that they have these long polymers. They're very thin filaments. You can think of them as like hairs that project out from the bacteria, and these things latch on to the lining of the urinary tract, and that's what allows them to become infective. So the big breakthrough here has been allowing us to determine an atomic structure for these pili, which will have many consequences in terms of public health. We start with electron micrograph, a very small sample, 2/1,000,000th of a liter. First it's frozen, is applied to a little copper grid, and then it's imaged in the electron microscope under liquid nitrogen temperatures. From those images, we have the ability to see atomic level or near atomic level of detail. We generate a reconstruction, which is that gray surface, which gives us the ability to build an atomic model into it. And the atomic model is the colored ribbons that are shown, and those ribbons represent the structure of the protein. The only way to understand the structure of these molecules is in 3 dimensions. We knew the general principle about how these things are assembled, which involves a strand sticking out of each protein that gets inserted into sort of the middle of the neighboring protein. But all the atomic details of this interaction were unknown until we've been able to show this. And knowing the atomic details is an incredible advance, because that gives us the ability to design drugs or other therapeutics against these pili.